Hey guys, welcome to Math for Friday. We're working on our fractions packet. So let's go over numerator, denominator. Denominator means how many pieces total. Numerator up top means how many are we talking about or how many do we have. So today we're looking at page number 3 and it's called equivalent fractions. Does anybody know what it means to be equivalent? What is something that is equivalent to something else? It's equivalent. Equivalent means it's the same amount. It's the same thing. So it says write the equivalent proper fractions for the pi models in each problem. So they actually don't make it too hard on you in that they color in the fractions for you. So all you got to do is find the denominator first, count them up. Oh yeah, 1, 2, 3, 4, 5. That one's 5 pieces, so 5 goes on the bottom. How many total pieces? 5. How many are we talking about? How many they color in? 1, 2. 2. That one's 2/5. And then with this one, they say, how many total pieces? Well, you've got to get your pencil out and probably just point to each one. It's 15. 15 total. How many are we talking about? Well, how many they color in? 1, 2, 3, 4, 5, 6. 6. So that's one way to do it. Just count in the pieces. How many total on the bottom? How many colored on the top? And these are all going to be equivalent because notice how it's the same amount that's shaded in both pies. So regardless of how many pieces they cut it up total, you have the same amount of shaded pieces. So it's like if you're eating pizza, you're getting the same amount of pizza. And I just keep using pizza because these look like pizzas. So you wouldn't really care that much if you got 2 pieces that size, or if you got 1, 2, 3, 4 pieces of pizza that size, because it's the same amount of pizza. The difference is these are bigger pieces. So it's like, do you want 2 medium-sized pieces or 4 small pieces? Either way, you're getting the same amount of pizza. So let's look at a problem like that for this. So I've got my 2 circles. They should, remember, if you're going to compare fractions, the wholes have to be the same size. You can't compare a large pizza and a small pizza. You got to compare the same size. So pretend like these are exactly the same size. And let's do 2 equivalent fractions. So I'm going to cut them both into halves, right down the middle. And now I'm going to cut them both into fourths. 1, 2, 3, 4. 1, 2, 3, 4. And now on this one, I'm going to cut it into eighths. So I'm going to cut it once this way and once this way. And now I'm going to color in one of these, one piece over here, and I'm going to color in the same amount of pizza over here. So notice how the same amount is colored in, but the fractions will be different, right? So what's a fraction over here? Well, I find it's the easiest to write the denominator first. So how many pieces total did we cut up? 1, 2, 3, 4. 4 pieces. How many are colored in? How many are we talking about up top, the numerator? Well, only 1. So that one's 1/4. And now let's do this one over here. How many pieces total? Well, 1, 2, 3, 4, 5, 6, 7, 8. How many are we talking about? 1, 2. 2. So 1/4 is equivalent to 2/8. It's the same amount of stuff. You just have smaller pieces and you have more of them. And here's something I'd like to show you. So that's how you draw it out. Here's something I'd like to show you. What if we then did another pizza, and I don't really have room for it, so I'm just going to do it to this one, and we cut each one of these in half. So let's see if I can cut each one in half. Cut that one in half. Cut that one in half. Cut that one in half. And cut that one in half. Okay, so now we've got to change our numbers, right? It's the same amount of pizza, but I just cut them all in half again. So remember 1/4 equals 2/8. But let's find out how much it equals over here. How many pieces do we have? Well, we just cut the 8s, each piece of the 8s in half. So what do you think it's gonna be? Do you notice any patterns going on here? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 pieces now. And how many pieces do I have? 1, 2, 3, 4. So 4/16 is also the same thing. It just means the pieces are way smaller. They're tiny little 16ths. So I have to have 4 of them to have the same amount as 1/4. But it's the same amount of stuff. So here's what I want to show you with that, is you can just keep doing that. I could do another one where I cut each 16th in half. And then what do you think it would be? Well, here's what I want to show you. You can draw it out and just keep cutting them in half like that and look at them. But you can also go like this. If you start off with a 1/4, whatever you do, you can just change these numbers in this kind of cool way where if I double the top number, I can double the bottom number. All that means is if I cut the pieces into twice as many pieces, I'm gonna have twice as many total pieces, and I'm gonna be talking about twice as many pieces. And I can do it again. Remember, I just cut the 8s into 16ths, so I cut those into twice as many pieces too. So I can cut those into twice as many pieces. So you can just kind of keep doing this forever until you get hundreds and thousands and millions. You can make the pieces very, very, very tiny. So 8 times 2 is 16, 2 times 4. Sorry, 8 times 2 is 16. So I've got to, whatever I do at the bottom, I do at the top. 2 times 2 is 4. And what if I cut them again? What do you think it would equal? Well, if I cut them again into 2 pieces, 16 times 2 is 32. And then 4 times 2 is 8. And I can just keep going forever. So that's kind of more of like a sneak preview of what we're gonna be doing later. So if this seems complicated right now, don't worry about it. Right now, all you have to do is just count how many pieces total right in the bottom, how many pieces are we talking about right in the top, how many pieces total on the bottom, how many pieces are we talking about on the top. But I want you to notice if you see what did they do, like how did they get from that number to that number. So 5 times 3 is 15, right? That means they cut each one of these pieces into 3 pieces. So then they have 3 times as many pieces. So then you have to do the same thing to the top. So 2 times 3 is 6. 5 times 3 is 15, 2 times 3 is 6. So when you're finding equivalent fractions, you're always doing that. Whatever you do at the bottom, you're doing the top. Because you're making more pieces. So just kind of notice as you count these up and count how many shaded, just kind of notice what's happening. And what did the bottom number multiply by? Because you know this top number will multiply by the same thing. And for these, they're probably all going to multiply by like 2 or 3 or maybe 4 at the most. So just look for those patterns. So today's math, we'll be doing page number 3. And remember, just look for these patterns. But if that seems too complicated, we'll have plenty of time for that later. All I've got to really do today is just count it up. How many pieces total? 4. How many are we talking about? 1. Is the same thing, I can tell because same amount of coloring, as how many pieces total? 16. How many are we talking about? 1, 2, 3, 4. Same thing. So all of these will be the same thing because they're equivalent. Just more small pieces over here. Same amount of stuff though. You can do it.